This is Tamil Raj from Tirupattur in Tamil Nadu. My qualification is MSc B.Ed, MPhil in Physics. I have a 16 years experience in teaching. First 3 years working in Indian Arts and Science College in Tiruvannamalai district, Tamil Nadu. Next, I have a 9 years experience in state board level. Okay, first 3 years working in Kanadasa Metric Higher Secondary School, Bargur in Krishnagiri district, and the next 3 years working in Sri Vijay Vidyalaya Metric Higher Secondary School, Krishnagiri, the same district, and next 3 years working in Vijay Vidyalaya Metric Higher Secondary School in Tirupattur district. Okay, and then I have 2 years in CBSE level in Vetri Vikas Public School in Rasipuram, Namakkal district. And then last 2 years working in NEET level. First 1 year working in Vetri NEET Academy, Dharmaburi district, and at present I am working in Spectrum NEET Academy in Salem. At present I am working branch in Rasipuram. Rasipuram branch I will working in NEET level. Now we are going to talk about the current electricity in one topic in Coulomb's law. Okay, first we are going to discuss what is the charges. The charges are two types. One is the positive charge, another one is the negative charge. And we are talk about the protons and the electrons. Protons are the positive charge and the electrons are negative charge. If protons and electrons are present in a atom. Okay, there are two kinds of charges only. Two kinds of charges. We are considered two same. There is a like charges. Like charges are repel each other. It is a like charges mean repel each other. Suppose we are considered two unlike charges. Unlike charges mean one is a positive, another one is a negative charge. We are considering one positive charge and one negative charge mean it is a force is attractive force. Okay, one is a repulsive force. This one is a attractive force. That is the two types of charges. The charges are experiencing a force. The force are explained in the Coulomb's law. The Coulomb's law in electrostatics. Okay, here we are considering here two charges. Already we are talked about the two charges are same charge are opposite charges. That means like charges are unlike charges. It is a like charges plus q and plus q are like charges. The distance between the two charges are r. We are considering distance r, and then here experience a force. The force is directly proportional to the square of the charges. Square of the charges mean the product of the charges. Here same charge mean here square with these charges. The product of the two charges, and then inversely proportional to the square of the distance between the two charges. Then we are going to write the final equation in force of electrostatics in K equal to Q divided by R square. Then electrostatic force F is equal to K into Q square by R square. Okay, it is we are considering same charge mean we are take about the Q square. Okay, then force F is equal to K into Q square by R square. It is a equation of electrostatic force. We are take the two charges are positive mean it is a like charge. Here experience only for a repulsive force. It is a force is a repulsive force. Then we are considering a unlike charges. The unlike charges mean one is a positive charge, another one is a negative charge. This is the unlike charge. The unlike charges are experience a force are attractive. Okay, the unlike charges are experience a force is attractive. It is a force. The electrostatic force are two types. One is the attractive force, another one is the repulsive force. The attractive force are experienced in unlike charges. The repulsive force are experienced in like charges. That is the electrostatic force. Now we are going to next. Here we are using constant. It is a K. The K is the proportionality constant. Okay. The value of constant K is equal to 1 by 4 pi epsilon naught. Here epsilon naught. The epsilon naught is the permittivity of free space. Okay, the epsilon naught is permittivity of free space. The value of permittivity of free space is 8.85 into 10 power minus 12 coulomb square Newton inverse meter power minus 2. That is the SI unit of permittivity of free space. Okay, next, the permittivity of free space means number of electric lines allowed to the pass the given surface is called the permittivity of free space. Now, here experience the force is F is equal to K into Q square divided by R square. That is a force. Here, these force are the charges are located at a air or vacuum. Then only create the force F is equal to K into Q square divided by R square. Suppose the same experiment, the same charge in same distance in kept in any other medium, the force will be changed. The force is depends on the medium. Okay, suppose we are introduce the one medium, we are the charges are kept in the one medium. Mean suppose we are charges kept to a water medium, then the we are kept in water medium, mean the permittivity will be changed. Then the equation, the force F is equal to 1 by 4 pi epsilon naught into Q square divided by R square. Here we are using epsilon r. The epsilon r is the relative permittivity. The epsilon r is relative permittivity. The relative permittivity of air or vacuum is 1. Suppose we are using in water medium, mean the relative permittivity is greater than 1. The medium mean the relative permittivity is greater than 1. Then only the force is changed in a medium. It is a free space. Equation is free space. It is we are using to the medium M. The Fm is equal to 1 by 4 pi epsilon r into Q square divided by R square. Now we are to relate between the air medium and in water medium. Okay, we are going to divide these two equations. Okay, this and this equation. Going to divide the two equation. Mean this is the first equation. Now we are taking Fm divided by F. The value of Fm 1 by 4 pi epsilon r into Q square divided by R square, and value of F. Now here this is considered to in reciprocal. Then the equation is we are taking in reciprocal, mean 4 pi epsilon naught R square divided by Q square. We are cancelled with 4 pi epsilon naught Q square R square R square. Then Fm divided by F is equal to 1 by epsilon r. Then Fm equal to F divided by epsilon r. Then force in medium is lesser than the force in air, or force in vacuum. This is a relation between force in medium and force in air. It is another one point. Then suppose the experienced force are directly proportional to the square of the product of the charges. That is a one. The magnitude of charge will be increased, the force also increases. And then distance between the two charges are increases, the force will be decreases. Why mean the distance, square of the distance is inversely proportional to the force. Next, we are changing the medium. The relative permittivity will be increases, the force will be decreases. Okay, well, the force is inversely proportional to the relative permittivity of the medium. It is the third one. The force is changing. Next, we are going to compare with gravitational force and electrostatic force. Okay, we are nature of force. Already know the four types of force are nature of force. One is a electromagnetic force, another one gravitational force, next is strong nuclear force, weak nuclear force. Okay, then here electrostatic force. The electrostatic force is a origin of electromagnetic force. The gravitation force, individual force of the electromagnetic force. Now we are going to compare with the gravitational force and the electrostatic force in atom. We are considering here one atom. The electrons are revolving in a nucleus around the nucleus, and the center of the atom are present in nucleus. Inside the nucleus are proton and neutrons. The nucleus is positive charge, electron is negative charge. The electrostatic force of proton and electron, and gravitational force of proton and electron. Now we are going to calculate and relate the gravitational force and the electrostatic force. Now consider two charges. One is the electron, another one is the proton. Okay, one is the positive charge of proton. Now consider two charge of proton is positive plus E. Next, charge of electron negative. It is also minus E. The magnitude of charge of proton and the charge of electron are equal 1.6 into 10 power minus 19 joule. Coulomb. Okay. Next, distance between the two charges. The protons are present in nucleus and then electron are revolving around the nucleus. Then approximately the value of the distance is 10 power minus 15 meter, or we are considered to distance is r. Here the electrostatic force in proton and electron is F is equal to the constant K and the charge E K, and then minus E divided by distance is R. Then magnitude of electrostatic force F into E square divided by R square. E square divided by R square. And then it is a electrostatic force. And now we are going to in gravitational force. The equation of gravitational force Fg equal to G into the mass of the proton. Okay, then mp. Next, mass of the electron me divided by distance between the two charges r square. Okay, that is the equation of gravitational force. Here capital G is a gravitational constant. The value of gravitational constant 6.67 into 10 power minus 11 okay, Newton meter square kilogram power minus 2. That is a gravitational constant value. And this is a K. K is the value of K 9 into 10 power 9 Newton meter square Coulomb power minus 2. Okay, that is a value of K. And then we know charge of proton and electron and mass of proton. The mass of proton mp equal to mass of proton 1.67 into 10 power minus 27 kilogram. Mass of electron is 9.1 into 10 power minus 31 kilogram. These values are substitute, and then now we are compare these two forces. Mean that we are take the ratio Fe divided by Fg. The magnitude of Fe divided by Fg equal to here K into E square divided by R square whole divided by G into Me MP divided by R square. We are cancel with this 2 R square distance, and then this equation is written as K into E square divided by G Me MP. Okay, this value is the approximately, so these values are substituted in this formula, and this we get the value is 2.4 into 10 power 39. Okay, 2.4 into 10 power 38. It is a approximate value. Then electrostatic force is greater than the 10 power 39 times in gravitational force. That is the relation between the electrostatic electrostatic force and the gravitational force. Now we are calculating the proton and the electron in atom. At the same time, we are calculating the proton to proton and proton in nucleus. Okay, this is also lesser than this value. Okay, that is value approximately 1.3 into 10 power 36. It is also some approximate value. That is a gravitational force is always lesser force in electrostatic force. That is a comparison. Next, we are going to how to calculate the force in a system. In a system, we are considered to now we are going to consider the one triangle. Okay, we are going to consider the one equilateral triangle. Equilateral triangle. It is a B, C. The side of the triangle is L, and three equal charges. Both are positive charge. We are considered two positive charge. Q, Q, Q are placed in a corner of the triangle. And next, the center of the triangle will be placed in a capital Q charge. Now we are going to calculate the net force at a capital Q. Net force at a charge capital Q. Okay. Now it is a considered two equilateral triangle. The side is L. Now first we are going to distance. Okay, we are going to calculate the distance between Q and Q. This is also Q and Q. This is also Q and Q. These distances are equal. The distance means this is a considered to A, B, C. Here considered to O mean OA, distance OA equal to OB equal to OC are equal. Now we are calculate this distance first. Okay. Now how to calculate mean here we are consider the equilateral triangle. The angle of the equilateral triangle is 60 degree. Here total angle is 60 degree mean here is 30 degree. Now draw the one straight line in this side. Here this one is triangle, right angle triangle. It is the angle is 90 degree. And then this point to this point O, sorry B. This point to this point B. Distance is the total distance BC is L mean here to here distance is L by 2. Okay, it is a half of the distance. This point is center of the BC. Then this distance is L by 2. And then now we are calculate this distance. This one the distance between the two charges. This one is a distance between two charges. Then OB. Now we are considered to angle. This angle, this triangle in cos value, cos 30. The angle is 30. The cos 30 equal to the cos mean adjacent divided by hypotenuse. The value of adjacent is L by 2 divided by hypotenuse value is OB. The value of cos 30 is root 3 by 2 equal to L by 2 divided by OB. Now here cancel with the 2. Then OB is equal to what value? L by root 3. Then value of OA, OB and OC equal to L by root 3. The distance between capital Q and any small q. Okay, any charge of small q is equal than L by root 3. And then the magnitude of charge also equal. Now we are going to calculate the electrostatic force. The electrostatic force equation F is equal to A into Q1 Q2 divided by R square Here K is constant, Q. One is the small q, another one is the capital Q, and Q divided by distance is R. The value of distance between the capital Q and small q, L divided by root 3. Then L divided by root 3 whole square. Then the equation of force is root 3 K into, here now F is equal to, the value F is equal to root 3 K Q divided by L square. That is the general equation. Now we are going into this diagram. Okay, here capital Q, this one is small q. This is a both are positive charge. Then direction of the force is away from the charge. It is a repulsive force. The repulsive force means this is a direction of the force. It is considered to now F1. And this are same charge. Then force is repulsive. Then direction of the force this side, it is a F2. And this charge and this charge also same charges. The direction of the force is repulsive. Then direction of the force this. Then this one is F3. We have three forces in a capital Q. F1, F2, F3. The magnitude of F1, F2, F3 are equal. The magnitude of F1, F2, F3. The magnitude of F1, F2, F3 are equal to root 3 K into Q divided by L square. Why I mean the charges are same and distance between the two charges also equal. Then magnitude of the three force F1, F2, F3 are equal. Then direction only change in these forces. Now we are going to consider these two forces first. Okay, the resultant force of F2 and F3. The resultant force of F2 and F3 in this direction only. It is considered to F dash. The how to calculate the F dash mean we are going to formula F dash equal to the square root of F1 F2. This force is F2 and F2 square plus here this force is F3 then F3 square plus 2 F4 F2 F3 cos theta. Now angle between this one is the 120. Angle is 120. Now here write the angle cos 120. Okay. Now the equation is going to write here. Okay. Now the F dash equal to square root of F2 square plus F3 square plus 2 F2 F3 cos 120. The value of cos 120 is minus 1 by 2. The value of cos 120 is minus 1 by 2. The value are substitute in this equation and then the cos 120. Cos 120 equal to minus 1 by 2 and then here magnitude of F2, F3 are equal. Now we are considered to the value F. It is equal to consider to any one F. Given value of F. It is equal to F. Okay. Now this also F square plus F square. Here cos 120 is minus 1 by 2. Cos 120 is minus 1 by 2 minus 2 into F into F square into 1 by 2. Here 2 cancel. F square is cancel. Then value of F dash equal to F. The value of F dash equal to F. The direction of F dash is in vertical upward. The direction of F1 is in downward. The F1 and F dash are equal force but opposite in direction. The F dash is also equal to F. This same value. The F1 is also equal to F. This same value. Here F1 and F dash are equal on the opposite charge. Then net force F net equal to F dash minus F1. That is equal to these two are magnitude are equal, but direction is opposite. Then net force of the center of the equilateral triangle is 0. Okay, well, that is a value. Suppose we are going to consider two unlike charges. Here we are considering like charges, then net force is 0. Suppose we are going to consider the unlike charges, mean these charges. Okay, here positive charge, we are considered to positive charge. Here also, okay, negative charge. This also negative charge. This also negative charge. Mean the corner of the charges are negative. The center of the triangle we are considered to positive charge. Now force is, the direction of the force will be changes. Here only direction is changes. Okay, how to change the direction of the force mean here. Now we are doing. Now we are considering here negative charge. Here also negative charge. This also negative charge. But the center is positive charge. Now the distance are same. The magnitude of charges are same. But direction will be changes. Negative charge, positive charge. The force is attractive. And direction of the force is this direction. Here also direction of the force is this direction. Here direction of the force is this direction. This one is F1, this one is F2, we are considering 2. This one is F3. The resultant force of F2 and F3 is, it is a F dash. Okay, here F dash and F1 are equal magnitude and opposite direction. There also net force is 0. Okay, we are considering a negative charges in corner of the triangle, mean also the net force is 0. Suppose the magnitude of charge will be changed in the corner of the triangle, mean the value of net force will be changes. Okay, the value of net force will be first button. Value of net force will be changes. Okay, there is a net forces in equilateral triangle diagram.